Hello, so this is the ninth lesson in Stats and Probability, topic 4, and it's called Combined Events. The previous one that we just did is we started probability, so now this is delving a little bit more into probability. So we're going to go through a couple of general things first. So the probability of A and B occurring, the way that we write that is probability of A, right? And then and is this little symbol right here, B. So we're going to learn a probability thing, and what this means is the probability of A and the probability of B happening. Generally, what we're going to be doing when we use and is multiply. There are some exceptions which we're going to go over in a bit. Um, and then there's another condition for combined events. You can, instead of doing probability of A and B, the probability of A or B. So there is a notation for that as well. Here's A, here's this, it's like, looks like a U. So probability of A or B. And so what that is means is the probability of A, there we go, or the probability of B occurring. And generally, the math that we do here is add. And we're going to talk about a little bit of exceptions. I kind of remember the and symbol, right, between the difference of it. It kind of looks like an A, right? So that might help you if to remember which one is which, all right? All right, so we're going to do a couple of problems here. So we have a box of, let's go green just because there is green here, and that's what we're asking for. So we have 3 green, 4 yellow, and 5 blue. We're going to assume that there are, like, each candy cannot be green and yellow or yellow and blue, right? It's just one color. And that is an assumption, which is safe to do. And we're going to choose one from a box. So what's the probability of choosing a green one? So probability of green is equal to what, right? We learned this last lesson. So the number of green, so there are 3 green out of the total number. So 3 plus 4, 7 plus 5 is 12, which this can reduce to 1/4 or 0.25. Okay, so that is how we answer the first one. Now, the second one's a little bit more interesting, right? It says, what is the probability of choosing a green or a yellow, right? So probability of green or yellow, it kind of looks like guy. What's the probability of green, right? We just found that out. 3 over 12. There's 3 green out of 12 altogether. And then probability of yellow, let's go like that. So this is going to be or, right, means add. And we're going to add the yellow. So how many yellow are there? There are 4 yellow out of 12. And so this is going to equal 3 over 12 plus 4 over 12 is equal to 7 over 12. And then I can take my handy calculator and just divide that. 7 divided by 12. Hit enter and I get 0.583 rounded to 3 significant figures. So this is about 0.583, and either of these answers work. Okay. All right. So this is a couple of questions about tables. So it goes into like a little bit more detail. So please read through these, see what you feel comfortable with, ask if you have any questions. So this gives you like a couple of scenarios, specific problems with this. So definitely go through that. And then we're going to talk a little bit more about this rule right here in a second. So there's combined events. All right, so the next thing that we're going to talk about is independent events. So one event has no effect on the other, right? So like the probability of me rolling 6 on a dice as well as flipping heads on a coin. So that one of them has nothing to do with the other. It's not like, oh, I have 50 marbles and I take one out, so now everything else is dependent on the one that I took out, okay? So independent just means has nothing to do with the other. So this formula is given to you in your formula booklet. So here's the formula, right? Probability of A and B is equal to the probability of A times the probability of B. And we talked about that above. So here's an example, right? An archer hits a target 2 out of every 5 shots fired. So the probability of a hit is 2 out of 5. Let's go ahead and just say also what is the probability of a miss, right? Probability of a miss, if they hit the target 2 out of every 5, they miss the target 3 out of 5. And I can prove that because 2/5 plus 3/5 is equal to 1. So now I have enough to go ahead and answer this question, and it says assuming events are independent, that one has nothing to do with the other. Um, so 3 arrows are fired. So what's the probability of a hit every time? So that's the same thing as a probability of a hit and a hit and a hit. So the math that we do here is the probability of a hit, which is 2 out of 5, times the probability of hit, right? Because one has nothing to do with the other. So we're going to do 2 out of 5 3 times. And when you plug that into the calculator, you're going to get 8 out of 125, I think it is. It's 8 out of 125. And when you plug that into the calculator, you're going to get 0.064. Okay, so please plug this into the calculator. Make sure that you get the same answers as I did. So what is the probability of hitting the first two? So probability of a hit and a hit, then missing on the third, and missing on the third. Okay, so hit and a hit, 2/5 times 2/5, right? And a miss, right? So the probability of a miss is 3/5, 3 out of 5, and this is going to give me 12 out of 125. And so when you plug this in, you're going to get 0.096, and either answer will work. Okay. All right, so now we're going to talk about something called mutually exclusive events. So mutually exclusive just means, like, for an example, in the candy example that we did, there's no candy that can be green and yellow, right? That's mutually exclusive, that's what that means. And so a probability that you can use for this is that the probability of A and B happening is going to be 0, okay? That means that, like, for example, the probability of it raining and not raining, that's 0, right? It's either raining or it's not raining. There's no in between, okay? Same thing with, like, the candy example. So this formula is given to you in the reference booklet. You do not need to memorize it, but in this case, like, what it means is you cannot have both A and B together, okay? So there are some examples that we're going to go over, and if something is not mutually exclusive, then the other general formula, and this is the one that we're going to use a lot. The mutually exclusive we don't really use that much, but this one we are definitely going to use. So the probability of A or B happening is equal to the probability of A plus the probability of B minus the probability of A and B, okay? So if it tells you that they're mutually exclusive, remember that probability of A and B is equal to 0. That's one thing for sure, right? And then the other thing is that the probability of A or B is equal to the probability of A plus the probability of B, okay? Why does that look like that? I don't know. Plus the probability of B, okay? So we're going to do an actual problem. So we have probability of A, probability of B, and the probability of A or B is 0.4. They are not telling us that it is mutually exclusive. So what is the probability of A and B occurring? So the first thing that we're going to do is the probability of A or B, right, is equal to the probability of A plus the probability of B minus the probability of A and B, right? That's the formula that we just got right here. And literally all you're doing now is just plugging numbers in. So probability of A is 0.3 plus the probability of B is 0.8 minus the probability of A and B. That's what we're looking for. So probability of A and B, I'm just going to leave that alone for right now. But they did give us the probability of A or B, which is 0.4, okay? So we can go ahead and combine like terms here. So when we do that, we're going to get 1.2. And then minus the probability of A and B, we have 0.4 here. So let's subtract 1.2 from both sides, minus 1.2. These cancel out. is equal to negative probability of A and B. And so when we do this, we get 0.8, because when I add these together, right, the 0.4 and the 0.8 gives me 1.2. And this is negative, divide both sides by -1, or multiply by -1, and we get the probability of A and B is equal to 0.8. So I just did something really quickly, and this is actually 1.1, and when I subtract 1.1, I get 0.7, 0.7, so my answer is going to be 0.7, okay? 70%. So there are notes just kind of explaining these, giving you some more examples, so definitely go through those, make sure you're okay with it, and then try the problems that are at the bottom, all right? Take care. Best wishes.